Welcome to the third session of algebraic expressions and identities. In the last session, we have learned the multiplication of algebraic expression. Today, we will see some more special cases of multiplication. Are you ready for that? First, let us see what is an identity and how it is different from an equation. Consider x plus 3 into x plus 4. That's equal to x squared plus 7x plus 12. We'll substitute the value of x as 1 and see what the LHS and the RHS is. Here when we substitute LHS, we get it as 1 plus 3 into 1 plus 4 equals 4 into 5, which is equal to 20. Now, for the RHS, we replace x with 1, that is 1 squared plus 7 plus 12, which is also is equal to 20. So, we can see that here the left hand side and the right hand side has got the same value. Now, let us take some other value for x. So, here x is given the value minus 2. As we did in the previous case, let us check for the left hand side. So LHS equals minus 2 plus 3 into minus 2 plus 4, which is equal to 1 into 2, that's equal to 2. RHS equals minus 2 squared plus 7 into minus 2 plus 12. Simplifying, we get the value as 2. This time also, we got the left hand side is same as the right hand side. You can try with any values of the x. The above equality is true for all values of the variable. So such an equality which is true for all values of the variable is called an identity. That is, an equality which is true for all values of the variable is called an identity. Is it clear, children? So an identity is an equality which is true for all values of the variable. Now let us see how it is different from the equation. As we did before, we will take an equation x squared minus 7x plus 9 equal to minus 3. We give the value of x is equal to 1. The LHS is changed as 1 squared minus 7 plus 9, which is equal to 3. And the value for the RHS is already fixed, which is equal to minus 3. So we conclude that here the left hand side is not equal to right hand side. We'll try with another value for x. So x is given the value 2 and the LHS is changed as 2 squared minus 7 into 2 plus 9, which is equal to minus 1. And for RHS, it's already given as that value as minus 3. So here also we see the left hand side is not equal to right hand side. Let us try with x is equal to 3 and see what happens. Here left hand side equals 3 squared minus 7 into 3 plus 9, which gives the value minus 3. And the right hand side is equal to minus 3. When you compare here, for the value x is equal to 1 and the value x is equal to 2, left hand side is not equal to our right hand side. Whereas when x was given the value 3, left hand side is equal to right hand side. So the above equality is true for certain value of the variable. So it is not an identity. This one we call it as an equation. Now let us see the case of standard identities. The first one which we deal is a plus b the whole squared. We know how to multiply any two binomials. So a plus b the whole squared is same as a plus b into a plus b. So that is equal to a into a plus b plus b into a plus b. That's equal to a squared plus ab plus ba plus b squared. By simplifying, we will be getting that same as a squared plus 2ab plus b squared. Therefore, a plus b the whole square is equal to a squared plus 2ab plus b squared. This is the first identity, or we call it as the first standard identity. A plus b the whole square equals a squared plus 2ab plus b squared. Let us visualize it like this. Here we have a square with side a plus b. Okay, now let's continue with solving some of the questions related to this first identity. Find the following squares by using identity. Question A, 7p plus 5q the whole square. Question B, 102 the whole square. Let's take in detail. Question A, 7p plus 5q the whole square. We know here we apply the first identity. First identity is a plus b the whole square equals a square plus 2ab plus b square. That means the square of the first term, that is 7p the whole square, plus twice the product of the first and the second term. So 2 into first term is 7p and the second term is 5q, plus the second term square, which is 5q the whole square. Now 7p the whole square means it is 7p multiplied with 7p. 7 into 7 gives us 49 and p into p gives us p squared. The second term, that is the product of 2, 7p and 5q. So 2 into 7 into 5, that's equal to 70. Product of p and q is pq itself. 5q the whole square means it is the product of 5q into 5q. That's nothing but 25q squared. So we will be getting the answer as 49p squared plus 70pq plus 25q squared. Now, how to find 102 the whole squared using this identity? What we do is, we split the number 102 as 100 plus 2 the whole squared. Now, it has been changed to the first identity form, that is a plus b the whole squared. That is nothing but a squared plus 2ab plus b squared. Here, in the place of a we have 100 and in the place of b we have 2. So that's equal to 100 square plus 2 into 100 into 2 plus 2 square. That's equal to 10,000 plus 400 plus 4, which is equal to 10,404. Now here are few questions for you to try now. Find the following squares by using identity. First question, 2x plus 3y the whole square. Question B, 103 the whole square. Question C, 0.3a plus 0.4 the whole square. Question D, m square plus n square the whole square. After you finish doing, you can check your answers. Answer to first question, 2x plus 3y the whole square is 4x squared plus 12xy plus 9y squared. The square of 103 the whole square is 10609. Now 0.3 a plus 0.4 the whole square is equal to 0.09 a squared plus 0.24a plus 0.16. Now m squared plus n squared the whole square is equal to m raised to 4 plus 2m squared n squared plus n raised to 4. Now let us see the second identity, which is nothing but a minus b the whole square equals a squared minus 2ab plus b squared. This one is also a standard identity. As we know the multiplication of binomials, we can write a minus b the whole square equals a minus b into a minus b. That is a into a minus b, then minus b into a minus b equals a squared minus ab minus ba plus b squared, which is equal to a squared minus 2ab plus b squared. So we arrive at the second identity, a minus b the whole square equals a squared minus 2ab plus b squared. Let us discuss some solved examples. Find the following squares by using identity. 2p minus 3q the whole squared and 298 the whole squared. As you see here, the question given is 2p minus 3q the whole squared. Because it comes as minus, we have to go for the second identity. So 2p minus 3q the whole squared equals the 2p the whole squared minus 2 into 2p into 3q plus 3q the whole squared, which is same as 4p squared minus 12pq plus 9q squared. So we got the answer as 2p minus 3q the whole squared equals 4p squared minus 12pq plus 9q squared. Let's start doing 298 square using the identity. We can write 298 square as 300 minus 2 the whole square. Now we got two terms here. We can apply the identity here. So that is changed as 300 square minus 2 into 300 into 2 plus 2 square, which is same as 90,000 minus 1,200 plus 4, which is equal to 88,804. Shall we try some questions now? Are you ready to solve the questions? Find the following squares by using identity. M minus 2n the whole square. Question B, 97 square. Question C, you have to simplify the expression 3a minus b the whole squared plus 3a plus b the whole square. Once you got the answer, you can check it here. The answer to the first question is m squared minus 4mn plus 4n squared. 97 square is equal to 9,409. And for C question, after simplifying, you will be getting the answer as 18a squared plus 2b squared. That's all for today. Today we have learned two identities. A plus b the whole square equals a squared plus 2ab plus b squared, and the second identity a minus b the whole square equals a squared minus 2ab plus b squared. Strength doesn't come from what you can do. It comes from overcoming the things you once thought you couldn't. Thank you, children. Have a great day.